Hello and welcome back to LPC channel. So in today's video, we are going to look at graphical representation of a set of data. So if this is your first time on this channel, please do well to like this video, subscribe to the channel and share with your friends and everyone who may be interested in this kind of videos. So in today's video, we are going to focus on histogram and frequency polygon, and we dedicate another video for cumulative frequency curve. So what is graphical representation of a set of data? Graphical representation of a set of data, we are talking about where the information that the frequency distribution houses actually helps us to present those information or those data graphically, and then we present those graphically whether in the form of a histogram, whether in the form of frequency polygon, or whether in the form of cumulative frequency curve. We also have others like bar charts, scatter plots, and those kind of. As we move along, we'll meet some of them, but for the purpose of this video, we're just going to focus on histogram and the frequency polygon, how information in the frequency distribution in a tabular form may be presented graphically. So we're going to focus on histogram and then polygon. So let's start with histogram. So what is histogram? So basically, we are saying that histogram, a diagram consisting of rectangles whose area is proportional to frequency of a variable and whose width or size is equal to the class boundary or class interval. So it's a diagram that consists of rectangles. Actually, for you to know that there is a histogram, you clearly see that it has a rectangular shapes, and then the rectangular shapes in terms of its length is determined by the relative frequency of that particular class interval. So we are talking about the area here. So the area that that particular rectangle will have on the histogram will be determined by the frequency of that particular class interval or the class boundary. Is that okay? And we are saying that here whose area is proportional to the frequency of variable and whose width, we are talking about the width or the class size, is equal to the class boundary or the class interval. You know, class width or class size can be found by the upper class limit or the upper class boundary, and then lower class. The difference between the two will fetch as the class size. So for us to get a histogram, we are talking about rectangular pass, right? And whose area is proportional to the frequency. We are talking about the frequency of that particular class interval will determine the area or a portion upon which that particular rectangle would have. Is that okay? So that is the idea about histogram. So you are saying that in summary, a histogram has rectangles that is based on a horizontal axis. So you're going to see these rectangles on a horizontal axis in the x and y plane. You'll see it on the horizontal axis. Centers are the class max. So for us to determine the center of any rectangular on the horizontal axis, we are saying that the center of that rectangle and its area that it covers can be determined using the class max, also known as the class midpoint. Right? And then the length equal to the class interval sizes. So basically, so the length of one particular class interval as against another is determined by the class interval sizes or the class width. And also it also has an area proportional to the class frequency, as I've already indicated. For us to know a proportion of area that particular rectangle will have on a histogram, it is depend on the class frequencies for that particular class interval or the class boundary. So let's take the example of a histogram that will help us to understand more what we are talking about. So you can clearly see that you start from 0, and most of the times histogram we leave some space in here, but then it's not compulsory. You can either leave the space or not, but the idea here is that because when we present data graphically in the form of histogram, then we are talking about a continuous data. So all data that is being presented in the form of histogram are called continuous data, because the reason we are saying continuous data in the sense that there shouldn't be gap or space left in between, meaning that if you move from 1, you're moving on to 2, and it continues to 3 and continues to 4. So there shouldn't be any gap between histogram. Is that okay? So that's actually what we are talking about. So you can even have your first frequency histogram rectangle be at the first here. You can leave the space, or I mean, it's not compulsory to have a space indicated here, but the only idea we are trying to talk about here is that make sure that the bars, there is no space or gap between what one bar as against what another. I hope that is clear. Because of what? Because all data that is being presented in the form of histogram deals with what continuous data. That's how there shouldn't be any what gap in between. Is that okay? And we said that the area that is covered by each rectangle determines the particular level of frequency that particular class has. So you can clearly see that the longest what this one, the longest rectangle here should clearly tell you that it has what the highest frequency. That's why it has what a large proportion of what area, right? Followed by this and followed by this, and likewise I think this and this are the same, and then the least one is what this. That's from 49.5 to 59.5, which is the class boundary. Is that okay? All right. And we also said that for us to locate the center of what the rectangles which forms a histogram, we are saying that we said it is the midpoint of what? The midpoint of what? Each what rectangle. So the midpoint can be here. So let's say the midpoint can be here, right? And you also have another midpoint here, and then so you are talking about the center, the midpoint of what? Each rectangle, the midpoint here, then let's say the midpoint here. And once you join the midpoint of each bar, it helps us to form what we call a frequency what? Polygon. So most of the time, frequency polygon, we start from the origin, the 0, right? And then we join to the first rectangular bar here that form part of the histogram, the midpoint, and then we join the mid. So we are going to join the midpoint, and then that will help us to form what we call what? A polygon. So let's take note of that. So actually, histogram and frequency polygon are related in a sense that for us to get a frequency polygon is a matter of joining what? The midpoint of what? A histogram. Is that okay? Or joining the rectangles of what? The midpoint of the rectangles of what? The histogram, and that will help us to get our frequency polygon. So let's take note of that. So as we have already indicated, we are saying that when it comes to frequency polygon, this is a line graph. This is a line graph of class frequency against the midpoint. As I said, this is the line graph of class frequency against the midpoint. It can be obtained by connecting the midpoint of the tops of what? Rectangles in the histogram. This is what I was talking about. So we are just interested in the midpoint of the tops of what? The rectangles in the histogram, and that will help us to construct or represent data in a form of what? Frequency polygon. So we are saying that to complete the polygon, the midpoint at each end are joined to the immediate lower or higher midpoint at 0 what? Frequency. So this is what I was trying to talk about here. 0 frequencies here. So it means that you start from here and then join to the midpoint here, and that midpoint here, there, and then finally end here. Then you can even extend it so that you know that you are actually what? Drawing what? A frequency polygon. So let's take note of that. So that is the whole idea about frequency polygon. And then this example was what I was talking about. So just joining the midpoint of what? Each rectangles in the histogram, and that will help us to get what we call a frequency what? Polygon. So let's take note of that. So let's take an example. The number of US citizens who acquired their residential permit in the year 2018 is presented in a table below. So these are the number of citizens here in class interval, and then the number of frequencies that falls within each class or interval here. We have 10, 8, 12, 6, and 9. So the question is, construct a histogram for this data and then determine the percentage rate of citizens in category 10 to 12. So we're going to use this question as a guinea pig to actually explain histogram and then that of what? Frequency what? Polygon in that case. So let's take note of that. So let me bring in my board here so that we start right away. So before we can actually construct a histogram for this set of data, we must first of all find out our class boundary for the various or number of citizens in classes form. Is that okay? So this is what we are saying, that to find the class boundary of this particular set of data, first you take the upper class limit of the first class and then subtract from the lower class limit of the second class. The results you get divide by 2, and after that you add the result to the upper class limit of a particular class limit, and then subtract from what the lower class limit of a particular class interval. That's how it should be. So here we are asked to construct a histogram for this data, and then determine the percentage rate of citizens in category 10 to 14. So before you construct, you first of all need to have your tabular arrangement of the set of data that's been presented here as the number of US citizens who acquired their residential permits in the year 2018. So first of all, you're going to have your class limit. So you're going to have your class limit. You're going to have your class limit. Your class limit. And then frequency. Okay. And then you can talk about our class boundary. Our class boundary. And likewise, we can also talk about our class mid. So let me have a column for class midpoint. So basically, this is how it's going to look like. You're going to have your class limit, your frequency, your class boundary, and then your class midpoint. Okay. So now, for your class limit, it has already been given here, as we have 1 to 4, and the 1 to 4 we have frequency of 10. Then we have 5 to 9. The frequency is 8, and we have 10 to 14. The frequency is 12, and we also have 15 to 19. Here is more of copy and paste, right? The frequency is 6, and we have 20 to 24. The frequency is 9. Is that okay? So we have here to be 20 to 24. All right. So once you're able to have this presented in a tabular form, we come to the class boundary. So the class boundary seems to know is going to be 0.5. You take this 4 from this 5 and then divide the result by 2. So it's going to be like 5 minus 4 and then divide the whole result by 2. You're going to fetch you 0.5. So for you to get a class boundary for the first class limit, you subtract 0.5 from 1 and add 0.5 to 4. So that's what we're going to do for all the class limits here. So here I'm going to have here to be 0.5 to 4.5. Okay, then 4.5 to 9.5, then 9.5 to 14.5, then 14.5 to 19.5, then we have 19.5 to 24.5. So this becomes your class boundary for various class limits. And then for you to get your class midpoint, it is basically your class limit, that's the lower limit and then the upper limit added together and get your class, and then divide the result by 2. That will help you to find your midpoint. So it is the lower class limit plus the upper class limit divided by 2, or it is your lower class boundary plus the upper class boundary, divide the result by 2, and that should fetch you your class midpoint. Is that okay? So let's see how we get a class midpoint. So here I have here to be 0.5 plus 4.5 will fetch me approximately will fetch me 5, right? So 5 divided by 2 is going to be 2.5. Okay, likewise 4.5 plus 9.5 here are going to fetch me 10. So 14. So 14 divided by 2 should fetch me 7. I hope you are following now. And then 9.5 and 14.5 follow suit. So here same thing, like adding the class midpoint divided by 2. So then I get 24. Okay, so 24 divided by 2 should fetch you 12. Then we continue. 14.5 plus 19.5, or 15 plus 19 divided all by 2, or the same thing as 14.5 plus 19.5 divided by 2. Okay, so we have 15 plus 19, so when you have 1 to add it to making it 20 here, so 34. So 34 divided by 2 should fetch you 17. Okay, and then you have here to be 44. 44 divided by 2 should be equal to 22. So you can clearly see that the first one was 2.5, second one was 7, 12, and then in that order. So let's take note of that. So that's how we determine the class midpoint. So that's how come we got our class midpoint. So when it comes to drawing of the histogram, right, you can either choose to use what, your class boundary or the class what, midpoint. But always, if you are to go by the class midpoint, it is best, I mean, it makes your work easy and what, simple. But you can also as well use what, your class boundary as well to actually construct the histogram. Is that okay? So this is how the diagram is going to look like. You're gonna have your vertical axis to be representing the frequency, and you're gonna have your horizontal axis representing the class midpoint. So you can also use what, class boundary to represent your x-axis as such, so that you can draw your histogram in this case. So here I'm using what, midpoint, okay? But always, because histogram is a continuous set of data, or data represented in the histogram are continuous data, we are to ensure that there shouldn't be any space in between what, one set of data or one class interval as against what, another. So there shouldn't be any space, but then you leave habitually some little space here to indicate a histogram. Is that okay? And then you tell us that the first one, which is what, midpoint of 2.5, had a frequency of what, 10. So you're gonna take it from here, and then you have your midpoint indicated. So let's say I'm taking it from here, right? So it is 10, frequency is 10, right? And have it here as my frequency indicated. Is that okay? Then you come to the 7, which is what, the frequency of what, 8, because 5 plus 9 is going to fetch me what, 14 divided by 2 fetch me. So midpoint is what, 7, and the frequency here is what, 8. So we take it from here. So we take it from here, and then that will help us to get our midpoint to the midpoint of the, all right. So after that, we come to the midpoint of 12, having a frequency of also 12. So that one too, just extend the midpoint of the 7 bar here, just extend it a bit. All right, because the midpoint, just extend it a bit, okay? And then have our midpoint indicated here to represent what, the 12. Is that okay? And then we move on to the midpoint of what, 17, which has a frequency of what, 6. So that one to pick it from here. All right, and then we have it represented as such. Because this is a sketch, actually I should have a proper graph, things would have been looking better in this case. And then we move on to a frequency of 20, a midpoint of what, 22, having a frequency of what, 9. So that one to just extend the last bar a bit to meet 9. So that's going to be in between what, 8 and then 10. That's what fetches as 9. So I'll just extend this small. Is that okay? So I can have my equivalent to 9, and then that should be the midpoint of what, the 22 bar here. So let me have something like so. This is how your histogram is going to look like. This is how your histogram going to look like. After that, you shade it, right? You shade it, very nice shade, and then you are good to go. That tells you the area that a particular bar is, I mean, covering, right? Or the portion of the area that particular bar is what, covering on the frequency. So just shade it like that. You just shade it a nice shade, and then you are good to go. Then you also shade, so you shade all, actually you shade all, so you shade all. So basically this is what we call what, a histogram. This is a sketch form of what, a histogram. Okay, so once you're able to sketch or construct a histogram using a graph, or whether in the form of a sketch, but always advisable to use for the graph. But here I'm just using a sketch for you to appreciate the principle I'm trying to put across here. So that is a histogram in this case. You can also as well use what, as I've already indicated, you can also use what, your class boundary. That will also help you to actually work best in that case. So once you're able to get your histogram, to construct your frequency polygon, it's just simple. It's just a matter of what, joining the tops, I mean the midpoint of what, the various rectangles bars that we have here in the histogram. Is that okay? But then we take it from what? The lowest what? Frequency, right? Which is what? That should be what? The 0 in this case. So this is what I mean. So let me have blue indicated here. So you just pick it from here, all right? So and then to meet at the midpoint of H, right? And then we come to, so this is how actually we join the midpoint of the tops, all right? And then bring it down here. So you are just joining the tops in that manner, and then can as well bring it at the, if there is any other frequency, just indicate like that. So the midpoint at each tops here forms or changes the diagram from histogram to what? A frequency what? Polygon. So this is how a frequency polygon look like. It's all about joining what? The tops of what? A histogram, and that will help you to form what? A frequency what? Polygon. But histogram, as I've indicated, is a continuous data, and so therefore there shouldn't be any space from one set of data as against what? Another. Is that okay? So the basic that's how we construct histogram and then a frequency polygon. But then we were told that we are asked to find the percentage of category in the class interval, which is what? 10 to what? Or class limit 10 to what? 14. So to find the percentage for a particular, in this case 10 to 14, so the percentage for 10 to 14, the percentage rate for 10 to 14 is going to give us what? It's a matter of what? Taking the frequency, which is 12, and then divide by the total frequency. The total frequency here is a matter of what? Adding all the frequencies of what? The various what? Class limits. So 10 plus 8, 18 plus 12, 30 plus 6, 36 plus 9 should fetch you what? 45. So 12 divided by 45 and then multiply by what? 100, and then multiply by 100. So let's pick our calculator here. So you have 12 divided by 45 and then multiply the result by what? 100%, and that should fetch you something like 26.67, approximately 2 decimal places, or possibly if you want to run it as a whole, it becomes what? 27. So we can say that approximately to the nearest whole should what? 27%. So this is the percentage rate of what? A US citizen who actually acquired their permit within this range, which is what? 10 to what? 14. They were having a frequency of what? 12. So let's take note, and then the percentage rate is what? 27%. So basically that is the whole idea about what? Histogram and then frequency polygon. So this is what we bring an end to today's video. So if it was really helpful to you, please go ahead to like this video, share, and then subscribe to the channel as well. So I'll see you in the next video where we talk about cumulative frequency curve. Bye bye.